Hello, Teck Chun.
Hello, hi, Jiaxing.
Hi.
Hello.
Yeah, can't believe we are nearing the end of January.
Yeah, oh, time flies. This year is
Yeah,
going to be fast again.
yeah,
Yeah,
yeah.
yeah.
So, hi everyone. Thanks for joining us today. We hope you are having a great Wednesday evening. And I'm Jiaxing from the Google Developer Relations team. And this is Teck Chun from Go Singapore.
Hello, guys. Welcome back. Happy New Year. Welcome to 2021. Hope you are safe. Yeah.
Yeah. Before we begin today's session, let me just briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups from around the region to learn and connect with one another. And as part of the developer relations team, we aim to empower and connect the community to our people, programs, network, and technologies. And we are really excited for the awesome speakers we have joining us today. And without further ado, I'll hand the stage over to Teck Chun from Go Singapore to share more with us.
All right. Thank you, Jiaxing. All right. Hello, guys. Today we have two speakers. One from South Africa, Cape Town. We have Oliver, who's from Brankas, and he will talk to us about Go worst practices, right? How to avoid failure. And then with second speaker is from Alexander, and he will talk about how to maintain high quality standards for your projects in test automation, both in theory and in practice. Right? And okay, without further ado, let us welcome our first speaker, Oliver. And over to you, Oliver.
Cool. Hi, guys. Can you guys all hear me quickly? I mean, can you hear me fine? Cool. Okay. So, yeah, my talk is called Go Worst Practices. As you've already heard, I'm a developer from Brankas. I used to, in a previous life, be a Clojure developer. I used to do a lot of full stack work, and I used to work with a really weird database called Atomic. And then around a year and a half ago, I switched to Go and Kubernetes, and yeah, I haven't looked back. These days, I do more infrastructure and some backend work. Yeah, so why is this not a talk about best practices? Well, for that, I really like this quote by Dave Snowden. And basically, in terms of evolutionary biology, there's a lot of good evidence that suggests that avoidance of failure is a much better evolutionary strategy than the imitation of success. And this is exactly why, parables and things often have like negative consequences, or bedtime stories for kids are often a little bit dark. And the reason is because you learn best through failure. And we're all a testament to that, because as a kid, you probably hurt yourself, like you burnt yourself or whatever. And no matter how much somebody explains to you that, fire is hot, it's only really when you go near fire and you experience the heat that you really understand. So that's why I think it's incredibly valuable to learn from failure. And then the second reason why best practices, following best practices doesn't always work so well is because what is best practice? Right? It depends on the context, it depends on the time, it depends on the stage of a company's growth. And you often see like people calling things anti-patterns in the community, like don't use the database as a queue, for example. But there's a lot of companies that very successfully use databases as a queue and don't use something like Kafka or RabbitMQ. And there's other companies that, the use cases kind of demand that they use a proper queue. But it doesn't make either of them less wrong. And I think when you think of systems in terms of, Dave Snowden likes to classify them in terms of ordered systems, complicated systems, and complex systems. In particular, software development tends to be around the complicated and complex space. And you really only have best practice in extremely rigid ordered systems. And in the more complicated and complex systems, you generally have good practice. You don't have best practice. So that's why I think it makes more sense to focus on what not to do and kind of just be able to choose practices that make sense to you rather than blindly adopting somebody else's best practice. So this is just going to be basically a opinionated list of what I think are bad practices in Go. And this is definitely something that should be challenged. What I'm really just trying to start here is I'm trying to start a conversation. This is the first iteration of this talk, and I probably haven't prepared as much as I'd like. I'll probably expand this talk in future. But the point is that these are like my thoughts on this, and I might be wrong. And I welcome anybody challenging me and just to start a debate about this kind of thing. And the idea is just to come up with a list of things that I guess most of us can agree that probably should be avoided. So the first one is large interfaces. And I think Rob Pike says it best when he says the bigger the interface, the weaker the abstraction. And I'd like to invite you to do a thought experiment. So instead of the really nice IO reader, seeker, closer, writer interface, let's just combine it all into one giant IO interface. This is obviously a terrible idea, but why is it a terrible idea? So if you look at the function do something, the first do something takes io.io, and the second one takes a reader closer. So, I mean, which do you prefer? Clearly, the first one doesn't tell you much. You look at do something, and you see io.io. It could do anything. It could read from a file. It could write a file. It might seek. Who knows what it does? But when you look at the second one, it's pretty clear that you're going to read from a file, and you're probably going to hopefully close the file afterwards. So I think in terms of understandability and readability and maintainability, it just makes a lot of sense to have smaller interfaces that can compose well together. And I think the IO interfaces in Go are particularly really good at this. So this comes from a book called The Philosophy of Software Design. It's a really great book, and he talks about modules, not Go modules, but he talks about a module as kind of like an interface plus its implementation. So what he recommends is that you have, so in this diagram, the interfaces are represented by, I should make this full screen. Interfaces are the dark gray, and functionality is the light gray, and the area of each square represents basically the amount of functionality. So both these rectangles have equal amounts of functionality, but you can see the deep module has a narrow interface and offers lots of functionality, which means the interface itself hides a lot of complexity. And conversely, the shallow one has like the same amount of functionality, but it's got a much wider interface, which makes it a lot less useful to use compared to the first one. So I like to think of deep interfaces as exactly IO, reader, writer, those sort of interfaces. And sort of shallow interfaces are the epitome of having like something like io.io instead, even though it's possibly not even the most terrible interface you can come up with. I mean, certainly some like really large interface that would be really bad, but that's just an example. So in the book, they say that the best modules are deep and accessed through a simple interface. And the problem with a shallow module is that it has a relatively complex interface, but relative to the size of the interface, there's not actually that much functionality. And the main point is that it doesn't actually hide that much complexity. And that's really what you want from an interface. Otherwise, like, why even have an interface? I mean, if you think of like your like a power socket in your house, it allows so many different appliances to connect to it, and they don't care about how the electricity on the back end is generated. Like, it could be wind, it could be solar, it could be coal, it doesn't care. And that's just because it implements like a very narrow, well-defined interface. And as such, it hides like an extreme amount of complexity from you. And I think that's what you want to go for when you designing your interfaces. So the second thing that I see a lot is interface pollution. And I guess the easiest way to define this is just using an interface when you really shouldn't use an interface. So Dijkstra said that the purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. And I think this is like a really good way to think about abstraction, because abstraction isn't about making things general and vague. It's about actually reaching a level where you can be very, very precise. If you go back to IO reader, for example, you have reader, you have read, write, seek, and these are like very, very precise things. And if you look at if you looked at like a file implementation, or particularly if you go down to the Unix level, I mean, that's like hundreds and thousands of lines, and it's all abstracted away by like a simple read, write, close, seek. And I think that's pretty amazing. And that's an example of how, having a good interface gives you that kind of precision. So here's another example of interface pollution. So I see this quite often where people will they want to have like a user database. So they'll immediately start with interface, and they'll, create this bloated interface. And then worst of all, like in the new method, they'll return like the UserDB interface. So now you've done a bunch of things. Firstly, you started with an interface. So you don't have enough examples at this point. You don't have enough data to make like a good abstraction. Like people that came up with IO reader and the Unix like file IO interface, it didn't just happen overnight. Somebody didn't just go home and think about it, without any experience, and just write that interface. I mean, it came from years and years of seeing lots of different IO, seeing like lots of complex programs use these things. And then from that, it was distilled into this interface. So there's this kind of wrong conception that people just go into like a cave somewhere and then come up with a good interface. Like, it's actually a lot of work, and I think it's really hard to come up with a really good abstraction. And then secondly, you're forcing your interface onto the implement, onto the person using your package. And Go is special in the fact that it doesn't explicitly force you to declare an interface. You can implicitly require any interface that you want. So that gives you a lot of power, because what it means is you, as the designer of the package, you can basically defer the hard work of coming up with a good abstraction that might be completely wrong for your users. And instead, you can give them the power to kind of implement whatever interface makes sense for their application. And then the final sin of this thing is that it's just not decoupling anything. It's not like the interface is exactly the same pretty much as the concrete type. So it's, again, if you go back to that deep model picture in your head, it's again like the shallow module. It's not really doing much for you. Yeah, so this is basically what I said earlier. It's just that you should really take advantage of Go's implicit interfaces. Like, they're really a really great thing, and like, I think this makes Go like really unique among languages, because I haven't really seen this before. And I think it's really important because it lets you, like I said, defer those really hard design decisions. So here's what you should do instead. You should just define the concrete type, use the DB as a struct, and return like the struct to the user, and just implement the methods, because really you don't need to have an interface here. There's no reason. So I hear some of you probably thinking like, okay, I need to mock, right? But I'll get to that in the next section. So when do you actually need an interface? Well, there's a couple of, and I took this from Bill Kennedy's post on interface pollution, which I highly recommend people read. But basically, do you need multiple implementations? So for example, I use a DB. We're probably not, unless we have some very special app, we're probably not going to be using Postgres and MySQL and SQLite, right? We're probably just going to be using Postgres. I mean, that's what 90% of apps probably do. So in this case, we definitely don't need multiple implementations. Secondly, you might want to decouple from some kind of expected change. Like maybe, your boss wants to change from using Postgres to MySQL for whatever reasons, or from SQL Server to Postgres because it's open source. If you're kind of expecting those sort of changes and your company is quite volatile, then maybe it might be a good idea to create an interface, but otherwise you probably don't need one. And then the last thing is, if you obviously have some kind of user-defined behavior which you need the user to implement, then obviously you have to have some kind of interface. So it's not that interfaces are bad, it's just that I think they're like salt. You want to use them sparingly and when you really need it. And if you want a good example, there's Arden Labs actually has a repo called Service, which I think they use for their teaching. And it's basically like a sample app. And if you like grep through that code base and you search for interface, there's basically nothing. Like the entire application doesn't define a single interface. And I think that for me is like an example of like, I think a well-designed app. I mean, it's a toy app, sure, but I think a lot of applications probably could do with a lot less interfaces. So back to the mocking point, I think that excessive mocking is a really bad thing. I know a lot of people like love testing and love mocking. And I don't think mocking is never something that you want to do. But I think that this kind of tweet kind of emphasizes what I'm thinking, and that's basically mocks never break, and you never have to deal with a network. And I know that's partly the point of mocks, but the fact is, if you're never actually testing the real thing, then how do you know it actually works? And you kind of have the law of distributed computing where you can never assume the network's reliable, and you have all these things that you're just never testing, and your mock's never going to break on you. And basically, you don't really have 100% coverage then. Not that, it's also debatable whether you care that much about getting 100% coverage, but yeah. So you don't really need mocks. What I recommend always is just test against the real thing. Like, if you're going to be using that user DB interface, like use the concrete type and test against Postgres or whatever database that you're actually using. You don't need to mock it, because then like the code that you're writing actually works against the real thing. And also it lets you take advantage of the features of Postgres that you might not otherwise be able to take advantage of. Like I remember at an old company I used to work for, we used to test, we used to do that standard practice where you test against like something like SQLite or H2 if you're in the Java world. And then your real implementation runs against Postgres. And presumably then you kind of just use like a very limited subset of SQL, because obviously H2 and SQLite don't support everything Postgres does. But then we had like an event store system, and we basically reached a point where we wanted like we were storing kind of JSON strings in the database, and we kind of wanted to use Postgres' JSON B type, which is obviously much more performant and lets you do things like indexing. And now we couldn't do that because we're testing against H2. So eventually we did do that, but then all the tests broke, and we kind of had to make sure certain tests ran against H2 and certain tests would just not be run actually. And that was really bad. And in the end, we had to just set things up so that Postgres could spin up in a container and we could just test against it. But that's what we should have done from the start, and would have avoided a lot of this kind of headache. And also then it really, really works in production, which I think is, it gives you a kind of confidence that you can't get, I think, from mocks. And you certainly don't want to be the guy that's debugging the really hard thing late at night. So if you do need an interface, then definitely the implementer of your package, the user of your package, can just define whatever interface they need. And this blog post is really good, gives a really nice example of how easy it is to just have the implementer define whatever interface that makes sense to them, and then test against that if they need to mock. So this is probably a controversial one, like dry, do not repeat yourself. It's kind of drilled into our heads from, like it was drilled into my head at university and ever since. And people kind of are obsessive about this, not repeating yourself, like extracting functions, extracting helpers. And I just think that there's nobody thinks about the overuse of this and the trade-offs that it has, because everything in engineering has trade-offs, right? There's no rule that applies to everything. So this is kind of a real example that happened in code. It's a simplified version, but I had this function upload to S3, which took a file, and it would return a path, and then the implementation itself would figure out what the path is. I think that particular one put it at some kind of random location in a UUID with the file, and then we'd write that to the database so we knew where to find the file again. And then we had 1 or 2 handlers using this, so somebody took it and they extracted it into a helper, which seemed kind of useful because it's a bunch of code, and now we have it condensed into one place. But I ran into this really cool tweet thread by this guy Sebastian, and he's I think principal developer at Unity, and he said the number one problem in big code bases, I apologize for all the words, but it's really worth reading this. The number one problem in big code bases is entangled code dependencies. If you make code too generic or extract code too soon, you end up with more dependencies. Code used by 2+ call sites tend to eventually bloat with complex control flow, bad performance, hard to understand and modify. So here's an example of that. So now I had to add a new handler, and this handler, unfortunately, I wanted to actually specify the path myself, where it was going to upload, because I wanted to use something I wanted to put the file under a particular organization, for example, and then I wanted it to be /organization and /the file when I wanted to find it later. And now suddenly the helper, is kind of getting in my way, because now I need to add this path override, and now the information gets bloated, because now if there is a path override, then I'll just use that path, and otherwise I have to do the other random interpretation. So the simple helpers actually added a lot of complexity. And if I remember in the old code, it wasn't this simple. It was a lot more code and a lot more things that could go wrong. So as soon as you pull out a helper, it looks like it's helping, but in reality, it's just you've added a dependency to each of these functions now that they never had before. And that can be good or bad. I think what I like to think of it is there's basically 2 types of things. Sorry, let me just get my train of thought here again. Just checking my notes. So I think this quote pretty much sums it. There's 2 types of long functions, entangled and linear. And if you avoid dependencies, then you can often write really long functions which progress perfectly linearly. Trivial to read, modify, and understand. No jumping around the code base. So if you go back here, you'll see imagine this was a really long function. I'd have to jump around all the time to understand the code. It's much easier if you don't have helpers from that sense. And then he says it might seem like it's a good idea at first to split a bunch of long functions into small functions, but you ruin the reading experience and you introduce a bunch of dependency between these functions. And basically what you're doing is you're adding risk in the sense that now, to modify those functions means that I'm potentially breaking other functions. So just everything becomes a lot harder from that sense. So I think how much to try, basically, the rule of 3 is a good default. I think if you have 3 examples, that's probably enough. But what I've experienced is that when you're in a project that's moving really quickly and code's changing quite often, then I think you probably need more examples than that, to be honest, because I've seen a lot of like dry code in fast-moving projects that just kind of gets in the way because the helpers aren't that helpful, because you end up having to modify them anyway and potentially break a whole bunch of other things. So this is a personal pet peeve of mine, which is like when I see there's no timeouts being set. And I think I blame this largely on the fact that when, like, a lot of library use is marketing, right? So people want their libraries to be used. And then naturally, when you look at the GitHub page and you look at the README, it'll show you like the simplest, most trivial example of using the library, just to illustrate how easy it is. But almost often these libraries just don't show like the production setup. So people just copy the sort of like trivial example into production code, and they don't really think about things like timeouts. And to make this worse, a lot of databases and things have infinite timeouts, probably for good reasons. Like, I'm not going to get into that, but it's just good to know that if you're not setting a timeout, the timeout's probably like infinity. So it's going to wait forever. So this is an example of setting a timeout in Postgres, and you can set like a connect timeout, and you can set a statement timeout, which will make sure that if you have a connection in your pool, that it doesn't get stuck. And this actually happened to us. We had a sign-up server, and the sign-up server was basically using Postgres, and it would get stuck. Like, it wouldn't be able to accept any connections, any new connections, HTTP connections. And it turned out that what was happening was somebody had forgotten to close like a row, and the connection pool was just filling up, and it would eventually there were no timeouts, so it would just stay full at that point. And any new requests coming in couldn't get, would try and grab a connection and would just hang. So what timeouts buy you is not getting your services completely stuck. Like, it'll give your ops team a chance to see that, okay, something's clearly going wrong. Like, if they're monitoring like the connection pool, or they're just monitoring the service, they'll see like the performance is degrading, but it won't just like stop completely like our server did. And it took a lot of debugging to figure this out, and it probably would have been a lot easier if we had these sorts of timeouts in place. And then naturally, I think Cloudflare has a really good post on timeouts in general that you should read. I'll try to get a whole bunch of notes up in a GitHub repo after this, or all my references and things I'll eventually put up. But basically, that's a really good article to read on timeouts. But yeah, you should definitely be setting read timeout and write timeout. This also protects you against malicious people. Like, a good way to check if your timeouts are working is to do a type of DDoS called a slow LoRa's attack, where you just like open a bunch of connections and slowly send bytes through, and it'll quickly tell you if you have like timeouts in place or not, because you'll soon run out of file descriptors if you don't. And then obviously on the client side, when you're making API calls, which is a lot of our job involves, like, you definitely want timeouts here, because once again, you can't assume that APIs are reliable. They go down, and you need to be able to deal with the fact that they might time out sometimes. So next worst practice, I think, is not closing things. And this is surprisingly more common than you think. Like, it's quite easy sometimes not to close like a database row, particularly when you want to do something more complicated and you can't just defer the close. Not closing files, and generally if you open something, just make sure it gets closed. Like, make sure it really, really gets closed, because otherwise, you kind of just leak memory, and you don't want, like I said, you don't want to be the guy that has to debug, or girl that has to debug this thing in the middle of the night. Like, the server's just running out of memory, and usually these are like slow leaks, so they're not really like obvious. And yeah, those are kind of like the worst bugs to debug. So I think we're getting there with tooling. Like, I think static check can do some. I think somebody added something that could, but don't take my word for it, that could check if rows weren't being closed. And I think there's other linters that can check if files are closed and things like that. But it's definitely worth running those things and making sure that things are actually getting closed. So bad naming, this is probably more a general kind of worst practice in programming in general. And the two types of naming that I think are particularly bad are vague names, so calling something data or X, or it just doesn't help the person reading it. You always have to think of the person that's reading your code or maintaining your code later, because it's probably not going to be you a lot of the time. And just make sure that you name it something reasonable. And if you, like, naming is a cognitively demanding task, and it's probably the thing that fatigues like us as programmers most. So if you can get away with not having to name something, like if you can just abbreviate it or so it's obvious, then you should rather do that, or you should use an anonymous function if possible, and you don't have to name it. So if you can avoid naming, that's even better. It's better than giving something a vague name. And then what's even the worst ever with bad naming is wrong names, which is basically where, you might name a shipment an order when it, and this particularly happens, I think it's more common in like the business domain, where you just completely name things incorrectly. And then that just confuses people, and it can actually cause like a lot of bad mistakes to happen, because people are assuming this thing's, an order, and it's actually a shipment. And then the next worst practice is inconsistency. And this manifests itself in lots of different ways, but in general, if you call something like a parameter to a function, you call it db, and just call it db everywhere. It just makes it easy to grep the code base. It makes it easy to like understand things. Don't call something, sometimes call it database, sometimes call it db, sometimes call it storage. I mean, this is an extreme example, but you do see cases where people just name things differently, like the same thing. My dad's an architect, the building kind, and he has this thing that I really love, where he says that you can see a building was designed by an architect, because then even if it's ugly, at least it's consistently ugly. And I think that consistently goes a long way, particularly in large code bases, and particularly when you're working in a team, because that kind of being able to rely on a particular style, I think, is important. And the same goes for using libraries. Like if you see somebody's doing some kind of form handling, and they're using a particular form library, and they're using a particular validation library, and they're using a particular, database driver, then if you have to implement a similar form on the same project, don't go and like use your own form library that you prefer. Like, just stick to the style of the project. I think that kind of consistency goes a long way. And then the last point is something that I think a lot of Go presenters leave for last, is concurrency, because it's quite a hot topic. But basically, overreaching for concurrency, I think, is a big mistake. And here's partially why. There's this really great paper on Go concurrency bugs, where they analyzed a bunch of huge projects like Kubernetes, Cockroach, DB, Docker, and they just went through like the issues and found all the various bugs which mention things like deadlock, or basically bugs that deal with concurrency issues. And they found that this is one of the gems that they found. I think this was from Docker or Kubernetes. I can't remember which one, but one of those. And like the problem here is that you're getting a result, presumably quite an expensive result, and then you're trying to put it on a channel, and then the select basically will sometimes, even when the result's actually ready before the timeout, if they're both ready at the same time, the timeout, the scheduler can randomly pick one of them, and sometimes it'll pick the timeout anyway, even though the result's ready. And then what happens is you can never ever, like, that channel just stays blocked and causes a leak. So the fix is just to use the buffered channel. But what I really like about this bug is it illustrates how like complex CSP can be from the perspective of not making concurrency mistakes. And Go does make concurrency easy, certainly easier than a lot of other languages. But I think the point of this paper, and what the paper also shows, is that CSP isn't necessarily a way of making all concurrency bugs somehow disappear. And actually, when you look at the paper and the data, they actually find more mistakes being made from CSP than from traditional like mutex locking, unlocking kind of concurrency code. So it's worth bearing in mind that even though Go makes concurrency easy, that concurrency is always going to be, as far like right now, it's always going to be difficult. And if you don't have to make something concurrent, then don't. Like, there's a tendency, especially when you initially switch it on, I mean, I felt this too, to make everything, like use a whole bunch of channels and spin up a bunch of Go routines. But really, you should be benchmarking and checking, like, is this actually adding value? Because is it actually giving me some kind of performance increase? Because otherwise, you're just adding complexity for no good reason. And bugs like this are difficult to debug, and you don't have to deal with this stuff you don't have to. So yeah, that's my point. Concurrency is hard, and CSP doesn't necessarily change that. Maybe it might be in the future. It might be because people are kind of used to traditional locking, and CSP is still kind of new. But so maybe the future will show us that CSP developers actually make a lot less mistakes than traditional locking, but we'll see. And also on this point, really, like a single thread on a modern CPU can do a ton of work, like a real shit ton of work. So don't forget how much work a single thread can do, or a single Go routine. And this is great paper, Scalability, but at what cost? Where I think cost means like basically the configuration you need to outperform a single thread. I think that's what cost stands for. But basically, they wrote a really competent single thread implementation of a lot of these, like a lot of problems that like you typically use something like Storm or Spark or something like that for. And a lot of the times they could actually beat these systems until they used like thousands of CPUs basically in order to beat the single thread implementation. So I highly recommend this paper. It's worth a read. It'll change your perspective on single threaded stuff. And I actually have some personal experience with this because I once rewrote something that was processing statistics using something like a Storm cluster. And at that time it was using, I think, 3 nodes, and you had to have 3 zookeepers, the usual drill for those sorts of complex systems. And in the end, I was able to convince my boss to rewrite it as a single node with a single thread. And it actually, performed pretty much equally, and it was way simpler to run and maintain. And it went down a lot less, actually. So when you're coding Go, just remember that, a single Go routine, and most of the time you have concurrency built in because you're probably running an HTTP service or something, and then naturally each one of those are already running in their own Go routine. So you have that form of concurrency already. I work for Brankas, and we are currently hiring, so you can reach out on our career site, and I can take questions now.
Thank you, Oliver. Yeah, let me see. Looks like there are no questions posted. Okay. Right. Thank you for the sharing.
Cool.
If there are any questions, we'll post it there. Yep. Thank you very much, Oliver. Yep.
Thanks, guys. Thanks for having me.
Thank you. Right. Next up, we have Alex. And so just a recap. Alex will talk about test automation. Yep. Right. Over to you, Alex.
Okay. Hello, everybody. Wait a second. I need to share my presentation. Can you see my presentation? Yeah, I suppose you can see. So my name is Alex, and today we will talk about test automation theory and practice. First of all, Oliver, thank you very much. We have some process across presentation. Especially, I found that your part on interfaces very, very useful, and I believe that's very right approach. Meanwhile, I'm going to share quite different thought on mocking, and that's quite cool that we are together joining same Meetup and sharing more or less different view or different approaches on same tool set or whatever. So let me introduce myself first. I'm a software developer, and I'm in the industry for about 18 years. I work as developer, team lead, architect with main domain in distributed computing, security, and automotive. You may think what is common between distributed computing, security, and automotive, but basically there are 2 things. First of all is high quality process and code, and second thing is networks. So that's 2 areas which I'm usually working on with C++, Go, and Python. Yep, first of all, I'm C++ developer. and then I go developer. But anyway, I love meetups, especially Go SG. That's one of my favorite meetup. I usually speak here, and also I'm a big fan of big companies. During last 10 years, I was working in Samsung, Kaspersky, Autodesk, and Motional. Talking about Motional, I will have small hiring announcement at the end of this talk. So if you are looking for new challenges, please stay with us. I think I will take 45 or maybe 50 minutes as maximum. So please stay with us. And let's talk about testing. Basically, why I'm going to talk about testing. Testing is one of the, I would say, most important part of software development, because yeah, you can create code, and but you have to support it. Your code usually should work for multiple years. It's not just fire and forget. You should support it, you should extend it, you should implement new feature, and almost everything is just impossible without testing. So when we're talking about testing, we have multiple levels. I believe you already saw this testing pyramid multiple times, which include unit testing, integration testing, end-to-end testing. You might tell, hi Alex, that's not complete. I agree, that's not complete, and I will talk about much more type of testing during this talk, but on high level, this is core part of this pyramid. And on the low level, on low end of pyramid, you can find efficiency. On high end, you can find comprehensiveness, but also lower part is much cheaper than high part of the pyramid. And I believe this is incredibly important because, let's say, you can easily restart your unit tests. You can fix them, update something. So it's really cheap. But when you're moving up, price of your test also growing significantly. Let's say we in Motional work on autonomous driving system. And end-to-end testing for us means we have to upload our software into our car. We should put a safety engineer into this car. We should run the car on the road and do tests. So it's really very expensive. When compared with unit tests, which we can easily run as a part of our pipeline. And when you think about test pyramid, you have to make main accent on cheaper part, because expensive part, they are more straightforward in terms of how to test them. You can, let's say you have a web page, website, you can upload everything on your, I don't know what you're using, let's say Amazon Cloud, just run user-based scenarios, but you should spend time on installing everything, you should simulate user scenarios and so on. That's expensive. So when you're thinking about test, dependency between price is a really important part. So let's start from unit tests. Unit tests, from my point of view, is a main developer assistant tool. Unit test could not guarantee you that your system works well, but unit test can protect you as a developer from regression error. It can help you with system debugging because you're always able to run single test, check what's going on in inside your code base, and like that. So it's much easier for you when you have your unit tests. Also, with unit tests, you help your colleagues easy to read and understand your code. Why? Because basically when you create unit tests, you have to think a lot about your system design, because let's say if you have issue with writing unit tests for your system, most likely it means that you have issue with design of your system. I mean, unit tests almost always help you improve your system design, but at the same time, it help just a bit or from time to time with your architecture, because system architecture usually is on much higher level when compared with design, and it just doesn't cover it by unit tests. I will talk about technique which can improve quality of your architecture a bit later, but definitely it's not unit test which will help you with it. So unit tests, that's really simple to create with Go. As I told before, I spent a lot of time with C++, and on compared with C++ world, writing unit tests in Go is just so nice, it's so easy, and I always wondering why people may not write it in Go, because you're just making your life easier. You have an incredibly good embedded unit testing tool chains. And Go language design with packages, interfaces, and what is more important, circuit dependency ban, allow you to create unit tests much easier. So that's basically, if you remember, Oliver told about interfaces and packages. One of the most important parts, which makes unit test creation simple in Go. In Go, usually you have package, which includes some relatively small chunk of logic in a single domain. Also, your application contains multiple packages, and packages interact with each other through interfaces. And why they're doing it? Mainly because of circuit dependency ban. Because if your package somehow will need to refer to itself, Go compiler will just tell you that, sorry, I cannot compile it. Please fix circuit dependency ban first. So this is why we, just because of Go language feature, usually have quite nice and easy to support architecture. And unit tests help you just to improve it. So what should you test with unit tests? First of all, you should try to address object or, in worst case, package level behavior. You can achieve it usually with mocking. And if you think that mock is a bad idea to use, then do not think about unit tests and mocks as something which help you to check that system works correctly. No, purpose of unit test. This is not the purpose of unit test. Purpose of unit test is to help you with the stability of your code base. Unit tests help you with refactoring, because if your code behaved in one manner before, after refactoring, based on your unit test, you are able to check that your code still behaves like before. Yep, maybe from application level of view, your code doing is something odd. That's fine. That's absolutely fine. Your target is to check that your code works as before, nothing more. So you have external dependency. Mainly, usually you have these external dependencies as an interfaces. Just mock it. Don't think about just generate mock, or if you have some tricky case, you can write your mocks by hand. If you have a low-level API, definitely you have to mock it. Especially if you work with some system-level API, then you just do not have any other way, because you want to have stable tests. Stable test means you run your test 10 times, and all 10 times your tests gives you same answer. They failed or they didn't fail, but you do not want to see anything in between. So what's more, you have to always test your results, but not internal function call sequence. Sometimes, I would say quite often, kind of 50-50, unit tests are absolutely useless because they test call sequence instead of real behavior, instead of real output. I will talk about this a bit later. And you definitely have to avoid timers and sleep in your code. Main reason for this is usually we run our tests as a part of pipeline, our CI/CD pipeline. And CI/CD pipeline, again, usually we use a virtual machine for running it. On your virtual machine, you have no way to guarantee that same delay will happen in multiple application restarts. So, yep, if you have no way if you don't have any option how to remove delays or sleeps or timers, just try to make it configurable. For unit tests, for lots of cases, you may want to increase timeout because that could be the only way for protecting you from false positive alarms. So, external dependency smoking. And that's, again, talk about interfaces. We can have a function like this, which accepts some type, and the type can read something. You usually have two ways how to implement such code. Sometimes could be, for example, file. That's fine. Why not? You can do it. But when you start implementing your unit tests, you actually have an issue here. It's still solvable, but you should create your file first, most likely physical file, put some data into this file, and pass this file into your code. It's possible, but you should perform quite a lot of extra action, and you always have a way how to avoid it. Just use interfaces. And again, we have a reader interface, which allow you to do same read as before, same as file, but you can easily mock your interface and pass your mocked object instead of file. And you have much more freedom with mock on compare with real objects in terms of behavior testing. So that's why, especially when you're testing your border level, package level API, interfaces are really crucial. You have to use it. And test results, but not internal function call sequence, which I mentioned before. I believe you also saw something like this. You have your mocked object and huge chain of expects. I expect that method 1 will be called, method 2, method 3, when maybe method 1 again, method 2 again. Sometimes you even can find that log messages also appears in this chain. That's the worst thing which you can do with unit tests. Why? Because basically you do not test anything. You just test that your internal code will do calls, but let's say, what is the purpose of your unit test? You want to help yourself with refactoring later. Will it help with refactoring? Actually not. It will help your life even worse because you hard-coded your sequence internally. So just try to avoid this. You should check result, but not internal logic. You care what your function, your interface, your component produced for you. You actually do not care how your component did it. And that's very important when you create unit tests for you. Coverage and automation tips. when you start thinking about, okay, I definitely need unit tests for my project, one of the question is, which coverage should I try to achieve? Based on my experience, usually 75% is achievable, and it's good enough. 80% is better, and if you just start from scratch, I mean, you have new project, you have almost zero code base, it's fine. 80% is amazing. Trying to achieve more, usually you will fail. Or I saw 100% coverage in unit tests. That's possible, but it's incredibly demotivating. Basically, why? If you achieved so high level of test coverage, unit test coverage, what you have is you have huge amount of unit tests. You cover all tricky cases, and every tiny change in your code base leads to huge changes in your tests. So you changed one line in your code, and you changed, let's say, 15 lines in your tests. Most likely, you do not want it. And if you will faced with a team which has so huge coverage, usually they were unhappy about it, because just that's not the case which you really want to support. Unit tests and coverage degradation. That's quite a big problem. If you didn't add any thresholds as a part of your pipeline, coverage will just go down. Why? We're lazy, mainly because of that. Almost all CI/CD provides your way to protect you from such degradation. At least as I know, there are plugins in Jenkins, TeamCity, Travis CI, I believe in almost in lots of other as well, because you always have to add protection from coverage degradation. I mean, it's fine when your coverage grows up, and in such case you can even increase your threshold. Let's say initially you had a threshold at 70%. After I don't know, few sprints, you see that, okay, now I cover 75%. Okay, let's up threshold to, let's say, 72%. Yep, if you have 75% coverage, do not try to set such threshold, because tiny changes could lead to very small performance up, coverage up and down, like just a part of percent. But let's say if you will goes down from 75 to 74.5, you still do not want to have failed build. So just try to go up. And the very important part, which lots of people forget about, is you have to write your tests before or with your code, but not after. And first of all, yep, it helps you to improve your code base a lot in terms of design quality. As I mentioned before, unit tests, if you're unable to write, if you have issue creating unit tests, you have a bad design. So it helps you. And also, it prevents you, or more often your management, from deprioritizing test development task. If you, let's say, split coding, implementation coding and testing into two different user stories, okay, if you work with Agile, then quite likely your product manager will choose implementation and tell, okay, guys, we will implement tests later. When later? Oh, some days later. Do not do it. That's very important to have all your tests on the place when you create your code, because unit tests, it's mainly for you, for simplicity of your work. Fuzzing. Yeah. As I told before, you almost do not have a way to achieve 100% test coverage, unit test coverage, but fuzzing can help you with it. Unfortunately, I do not have a way to ask you to raise your hand if you do fuzzing, but based on my experience, I would expect just a few hands in audience. So let's talk about this incredibly important technique. So from my point of view, it's really one of the most wonderful testing technique. It doesn't help you to improve your code design quality, unfortunately, but it helps you to cover 100% of your code with such kind of test. By such kind of test, I mean you will catch all your crashes, which is really cool. And you will cover all your tricky parts, which otherwise almost impossible to cover with unit tests. Right now, there are two main tools for fuzzing is Google GoFuzz, which is, from my point of view, have low quality and at the same time it's less popular, or Duke of GoFuzz, which is more popular and quite, it's really a nice to use tool. So let's talk about second one. How fuzzing looks like. Actually, you need just to add one function into your tests, like this. Function which have only one argument and it accepts just chunk of bytes, nothing more. Sounds really easy. Just create one function and magic will happen. Fuzzer is a tool which manage fuzzing process. Fuzzer will generate random input. Fuzzer will monitor execution coverage, and based on execution coverage, it will return back and generate new random input. So it means input is not really random, it's pseudo-random. It depends on your code execution process. Also, Fuzzer will monitor crashes, panics, which happens in your code. If the only thing which Fuzzer can really detect is crashes or panics. It cannot detect that your code behaves not exactly the same as before. And you have unit tests for that. For Fuzzer is for crashes and panics. And if crash or panic happen, yep, it's unfortunate, but it happens, then it will Fuzzer will generate crash dump and write crash data. Crash data means data which leads to, unfortunately, event of crash. And let's have a small demo. Please wait a second. I should stop sharing this screen and share my command line. Terminal, yep. Let me check, yep, terminal. So I have just one file, fuzz demo, with the next content. This file contains incredibly stupid error, and actually this demo is typical demo which demonstrates why fuzzer is important. So if you pass to your function chunk of data with len of 3, then you check that first symbol is F, second symbol is U, third second is Z, and fourth is again Z. This is logical error. It's impossible to achieve because your size of your array is just 3 elements, but you do check for 4th elements. If you will think about unit testing, most likely you will just not able to hit this line, because when you code unit test, you think about positive scenario. You think about behavior which you want to prevent from unexpected changes, from kind of degradation. So Fuzzer do opposite. It trying to check cases which are not covered at all or really challenging to achieve. And as I mentioned before, we have only one function, fuzz, nothing more, which will do all fuzzing magic kind of for us. So how to run it? First of all, you have to install Fuzzer, something like that. I will not do it because I already have Fuzzer in place, but you should download Fuzzer and add it into your path. So let's say you did it. Second step is you have to compile your target like this, very simple. And third step is execute your Fuzzer. Yep, Fuzzer is running, and what you can see here. So we have one crash detection already, one restart, exact time, and some extra inputs. And let's check what we have. Crashes. Yeah, wait a second. So what we have after fuzzing was executed. So initially we had just fuzz demo go. Now we have corpus, list of dictionary which fuzzer use internally. We have crashes report, and we have session suppression, means you can continue your session in the future. That's internal fuzzer information. In our case, we care about crashes folder. So in crashes folder, we have just some output, quoted, and kind of magical file. Let's see internally. Exams, crashes, first file. So we have just fuzz. And if you remember from our example, if we will pass a fuzz string for our target, application will panic. Yep, that's what was detected by Fuzzer. So, oops. Output. This is our call stack. And so we have call stack, and we have data input which leads to your crash. It means you have a really simple way to reproduce your issue. You have input which leads to crash. I think it's very good because you should do almost nothing. You should just write one function and run Fuzzer. If your application crashes at the end, you will have exact data which leads to the crash. So let's return back to my slides. Yep. Performance testing. After we add unit tests, we add fuzzing, we may start thinking about performance. When you think about performance testing, good thing is it's really easy to implement. Almost same as fuzzing. You have your critical workflow, and you have a framework from Golang, which allow you to run your workflow multiple times and calculate average time execution and provide you other metrics. Very simple. But in real world, performance testing is quite challenging, mainly because of your CI/CD pipeline. As I mentioned before, our CI/CD pipeline usually do not use real hardware. we use some level of virtualization. We may use Docker, we may use any other type of virtualization, but almost never real hardware. But we have a problem with it. With virtualization, you can never be sure that between two execution of same code, you will have same result. When you have virtualization, it means your physical hardware shared across multiple instances of your virtual environment. Let's say during one execution of your performance tests, it's possible that your physical hardware execute just one instance of your tests. In second time, it could be two instances. And output of your performance testing will be different in this case. So if you use virtualization, you just cannot trust your output. And that's a big problem. So you want to add performance testing into your pipeline, you have to add physical hardware first. Then you should attach your physical hardware to your CI/CD pipeline. And here we have even more issues, because let's say if you use GitHub as your CI/CD, cool, you have actions. And actions allow you to implement performance testing, because what is the purpose of your performance testing? You want to be sure that you do not have any degradation across between your test's execution. And it means you have to use some storage which store tests results. And GitHub Action help you with it. But let's say currently in our company, we use Jenkins. And if you know how to add performance testing from Jenkins, it would be nice to share, because looks like we should implement this persistent storage by our hand. Yeah, correct. We should set up some database and do call from Jenkins for storing our data and retrieving it back. It's possible, but still extra action, and it costs some money for us. That's what not we want to do. Integration testing. That's, I believe, a very important part of tests. Why? So integration testing, the point of integration testing is to test whether many separately development models work together as expected. I grabbed this from Martin Fowler. And that's true, because quite often with unit tests, we have something like that, especially when we use mocking. That was highlighted during first talk. So you cannot trust your unit test in terms of system behavior. And the point is, you shouldn't even care about it. System level behavior have to be covered by integration tests. Unit tests and integration tests, they are trying to solve absolutely different tasks in absolutely different manner. What we're trying to solve with unit tests, with integration tests. Let's imagine we have project with structure like that. We have 5 components and our database. Components interact with other. Component A and component C have some inputs from outside, from the world, and they send data to levels back. Let's think about our architecture and our tests, what we can do here, and why unit tests, why integration tests will help you with architecture. As I mentioned before, unit tests will not help you with architecture. That's for design. Means unit tests will help to improve your component A internally, but most likely unit tests will not help you with architecture. And architecture means how component A interacts with component B, component D, how the whole system interacts with each other. So you have a world and small components. And unit test and integration test helps you to deal with the whole world. So, what we and how we should test, what we should do for writing good integration tests. First of all, integration tests simulate whole system, at least on component level. Let's say component A. You do not care how component A implemented internally. You care about component A input and output interfaces, nothing more. In some cases, you can think of integration tests like component A and component B together, like this. So, usually for implementing good integration tests, you start thinking on component level dependency mocking. So you do not need to mock your classes. You mock entire system. Let's say if we want to test component Z, what we can do here? We can create some fake database as an output. We can create a mock for component A and component C, which are input for our component Z, and maybe we will care about E, maybe we will not. So we may decide to separate E and D into a single test set or mock E as well. But the idea here is you do not try to test internal of your component, you just test behavior. Your component behave as before. And you can achieve it by multiple ways. Let's say you can record and send your traffic or events on your component, or you can create your code. You can create some code and implement like something like user virtually press a button or add some input. You just simulate workflow. And if your system is really complicated, then traffic or events replaying is better option. If your system is not complicated, let's say you have some desktop service or console utility, maybe better option would be just user action simulation. So it absolutely depends on what you are trying to cover, which workflow you are trying to simulate. So some tips on integration tests. First of all, integration tests are flaky. What that means? Because you test not one class, but system as a whole, it depends on lots of external events which you usually cannot control. Something may just happen in between. And in this case, you will have false positive alarm. You can deal with it by several ways. Let's say you run your integration tests. Let's imagine you have 100 tests, and you split these tests into subsets. One subset, critical tests. If critical test failed, you mark your build as failed. If some not critical tests failed, okay, that's fine. It happens. Not big deal. You can add some check like not more than 5% of non-critical tests may failed. It's up to you. Second way which is I actually prefer more is we execute our integration test set once and check which tests were failed initially. We have a list of failed tests, and we execute this list of failed tests second time. Almost usually, second execution should not fail. So if on second execution you still have failed tests, most likely this is not a flaky test, it's a real issue. If second pass succeeds, potentially it's a kind of regression, but usually you can just ignore it. That's fine, because integration tests are flaky. What should you use for integration tests? I almost always prefer to use Python. Yeah, I'm talking about Python on Go Meetup. And this is mainly because almost everybody able to read and write Python. I couldn't say so for Go. And in Python, you have library for almost everything, I would say. If you need to do something, just Google a few seconds and you will find library on Python. So you have a simplicity and you have huge choice of options. And third reason is Python is really good for automation, because it's allow you to create code fast. It's not compiled, but interpreted language. So you even able to log in into your build pipeline and change something on the flight if you want to kind of debug on the flight. So that's just easy to use. Except some cases when Python is too slow. I faced it with such situation when we had a integration test based on Python, but funny fact was Python was too slow. And let's say you have to generate event, let's imagine 1,000 events immediately, but Python interpreter took 2 seconds just to start up. So it's just, you just cannot use it. It happens. Not often, but happens. In such case, you should think about other tooling. Let's say you can switch to Go. But by default, Python easier to use. And last part is integration tests are very expensive. If you check some reports from big companies, and I tend to agree with such reports, you may spend about 40% of time on your development time on integration test, the implementation and support. So you can ask your devs to do it. It's possible, but would better to use SDET, who actually, first of all, can create integration tests better than developer. They have a bit different set of mind. And with such separation of work, you can cover more cases which otherwise will be just about which otherwise developer may just forget. So role separation is quite important when you're talking about integration tests. And last, hiring announcement. So we in Motional have multiple open positions. You can just scan this barcode and you will have link on all open position in Singapore. And you can even apply to position by yourself, or you also can send email to me, or you can reach me through LinkedIn. So you are welcome as you wish. It's up to you. Yep. Thank you very much. Do you have any question about my presentation?
Thanks, Alex, for the sharing. Very detailed. Let me see if we have any question here. Actually, I do have a question, Alex. What do you think about mutation testing?
Sorry, say again.
What do you think about mutation testing?
I never heard such term before. So can you please explain a bit? Because is it something similar with fuzzing? Because fuzzing also mutate your data and send something new.
And so fuzzing mutates your data, but mutation test actually mutates your code and see whether your test will break your code. So if the test breaks your code, that pass the mutation test.
Okay, I never hear anything like that before. Just a few days ago, I saw something more or less similar in C++ world, but there was not code mutation in terms of I have if4 and some function call and I will run them in different sequence, but that was more about let's add some change instruction sets, or let's add some delays in our code. But main purpose of that test was check performance, because based on your code order, you can have different performance, mainly because of caches, processor pipelines, and so on. So if it's something like that, and you have critical to performance code, it could be reasonable to use, but I'm not sure that it would be reasonable to have such code with implement such code in Go. Maybe C++ would be better options. But for Go, I never faced with such needs, let's say like that.
Cool. Actually, Oliver, our previous speaker has a question for you. Let me just post it on the channel.
I have a question from Oliver. What do you think about model-based testing? Yeah, exactly this. I never hear anything like that. Sorry, guys. So I have zero opinion about it.
Cool.
In a very fast-moving project with changing requirements, would you still have a batch of unit tests? Definitely. I believe this is the only way to have your project in maintainable state. Because without unit tests, you do not have a way to prevent your project from regressions. And it will. So for your management, your management may feel that tests cost a lot. But the truth is, if you will remove tests for, let's say, 1 or 2 months, you will move really fast. But after that, you will just stuck with a lot of different regressions. And what the worst here, you will have regression and have no idea why they're happening and when you introduce them. So anyway, doesn't matter how fast you are changing your requirements, tests should be in the place, especially unit tests and fuzzing. Because fuzzing, it's kind of about security. Unit testing is a tool for developer which help you with regressions.
All right. I don't think we have any further questions from our audience. So thank you so much, Alex, for the presentation. That was really, really helpful. Let me just. Oh, cool. Okay. Let me just close off the event. Thank you so much, Oliver and Alex, for the presentation. Very practical tips on that we can apply on our day-to-day work. Also, thanks to the audience who tune in and stay with us until now. We have another event from Go Developers Network later at 2 a.m. if you are still up. Thanks to Google DevSpace who helped us out today for our live streams. And I think that's it, folks. Good night.
Thank you. Good night.